Hello, in this section we're looking at 11.3 polar coordinates. To define polar coordinates, we first fix an origin called a pole and an initial ray from the origin. Okay, usually we designate the positive x-axis to be chosen as the initial ray, and then each point can be located by assigning a polar coordinate pair in which we give a radius, how many r's away from the origin, and the angle, the angle that we have, and it's a directed angle from the initial ray to um, to the point. Okay, so for example, our point are typically given like this. We have r comma theta. R is the radius, right? It's how many units away from the origin, and theta is the angle. Okay, so for example, our initial ray, we're always going to be drawing it off of 0. This will be the initial ray. Okay, so if I gave you guys, let's say, the point 2 comma pi over 3. Okay, well, we want to do a radius, so at radius of 2. And so, okay, so where would that be? Now, each of these, if we think of the pole, that's our origin, each unit is 1 radius, so that's r of 1. And then going up to here, this will be r of 2. Okay, now, at an angle pi over 3 is 60. Right? So that means we'd go 1, 2, and that would be the point 2 comma pi over 3. Okay. Now that's not the only way to express that point. We could say, for example, we could say 2 comma, and then if we add 2 pi to this, right, we could say 2 comma, and then if we add 2 pi to pi over 3, so we would have, let me do on the side here, 2 pi plus pi over 3, so 2 pi would be 6 pi over 3, so it would be 6 pi over 3 plus pi over 3, that would be 7 pi over 3. And of course we could keep wrapping around 360, and we get a lot of these. We could even describe the p in terms of a negative radius. Okay, so let's take a look at another example. It says find all coordinates of the point 2 comma pi over 6. So all the polar coordinates, right? So 2 comma pi over 6. So just to get a sense of what that is, 2 would be, and if we look at pi over 6, that would be 1, 2. We're looking at right there. Okay, so that means we have, for r equals 2, we have pi over 6, and then we could have every 2 pi after that, right? We could have, for example, we have 2 comma pi over 6 plus 2 pi. We could even do pi over 6 minus 2 pi. We go the other direction. So one thing we have to note is when we're giving the angle, right, from the initial ray, our angle is going to always go in the positive direction. We're going, right, just like we normally would. We're going counterclockwise. Okay, so plus 2 pi would be, we're going to go 2 pi, wrap it around counterclockwise. If we did minus 2 pi, then we're going to go clockwise. Okay. So if we could keep doing this, we could say 2 comma pi over 6 plus, we could go another 2 pi, so we could do like 4 pi. Or we could do minus. Right? Then that means we could say in general, we could say that this is going to be 2 comma pi over 6 plus 2 pi n, or 2n pi. And we could say where n equals 0 plus or minus 1 plus or minus 2. Right? As long as n is some integer, positive or negative, we could express the polar coordinate in that way. So now how do we express this with the negative radius? Right? So for example, we could express this with a negative 2. Now if we go negative 2 and we say pi over 6, that's going to bring us to over here. Right? If we follow the pi over 6 line, that means now we're going into 7 pi over 6. So negative 2 would imply right here. I'll do this in red. So negative 2 do negative 2, and that would be 7 pi over 6. Seven pi over 6. Right, now, so going 7 pi over 6 angle, that would go to here. And then if we go negative 2, that means that would then flip it and go in this other direction, so our point ends up here. Okay. Now notice if we just did, so that would still represent the same point, our original point. If we just did 2 comma 7 pi over 6, then that truly represents this point. Okay, because we're 2 away from the pole, and the angle is 7 pi over 6. If we do negative 2 comma 7 pi over 6, so pretend you're going 7 pi over 6 to here, and then if we do negative 2, we have to flip it, and that brings us to the positive 2 over 6, the positive pi over 6. Okay, so for this one, because we could add and subtract 2 pi from the 7 pi over 6, we could say that this is going to end up giving us negative 2 comma 7 pi over 6 plus or minus, put the minus here as well, no, Probably don't have to put the minus because we have it expressed as plus or minus 1, plus or minus 2. So we can say 7 pi over 6 plus 2 pi n. And again, where n equals 0, plus or minus 1, plus or minus 2, dot, dot, dot. Okay. All right, let's take a look at another problem. A circle or line can have more than one polar equation. So let's see. If we say r equals 1, right, if r equals 1, the radius of 1, that means that's going to fit this. This is radius of 1. This is radius of 1. Right? All these points are a radius of 1. So what's that going to create? It's going to create this circle. Okay, so r equals 1 will be a typical equation of a line. We could also say, for example, for this, we could say r equals negative 1. Okay, and you wouldn't be wrong there either. Right? R equals negative 1. And all those would be the same circle. Okay. All right, let's say we had theta equals something. Theta equals pi over 6. Okay, now pi over 6. These are all marked off in pi over 6's. We got pi over 6. 2 pi over 6. You could reduce 3 pi over 6, which is pi over 2. This is pi over 3. 4 pi over 6, which is 2/3 pi. 5 pi over 6. 6 pi over 6, which is pi. And you can just keep going like that. Alright, so if we have theta equals pi over 6, that would be this line. Right? And so think about it this way. We could also say theta equals 7 pi over 6. And that would be the same exact line. Right? 7 pi over 6 is here. And we're not specifying anything for radius. So that would be the same exact line. So it's another way of saying the same thing. We could also say theta equals negative 5 pi over 6. So if you think about it, counting from where 0 would be, if we go negative 5 pi over 6, negative 1, negative 2, negative 3, negative 4, this would be negative 5 pi over 6. That would also be this another way to write the same line. Okay. So a good lesson to come from this, if r equals a number, you're going to get a circle centered at the origin, and you count how many units for your radius. If theta equals a number, an angle, then you have a straight line, and you're just going through that angle, going through the origin in both directions. Okay. All right, example 3, graph the set of points whose polar coordinates satisfy the following conditions. Okay, so first one says radius is between 1 and 2, and theta is between 0 and pi over 2. Okay, so first of all, for a radius to be between 1 and 2, that means we would have the circles between 1 and 2, right? And then for theta to be between 0 and pi over 2, so 0 pi over 2. So there's the restriction on the angle. So only between here and here. That means it's only going to be this quarter section. Right? So let's do this. Let's erase. Okay, and the radius is between 1 and 2. So everything between, like this. Okay. Alright, let's take a look at B. Radius is between -3 and 2, and theta is pi over 4. Okay. Pi over 4 is going to be about right here. Okay, so pi over 4, and its radius is going to be between -3 and 2. So 2 would be 1, 2. -3 then would go the other way. 1, 2, 3. So that would be, it would be a line. It would be a line between -3 and +2. Okay, and then let's do part C. Theta is between 2 pi over 3 and 5 pi over 6. So 2 pi over 3 is 4 pi over 6. Okay, so this is 4 pi over 6. And this is 5 pi over 6. Okay, so that means we're going to be anything between. Right, so anything between. And for that matter, we could go into the other end as well. And so it'll be anything between there as well. Okay, any questions? You can bring it up during the lesson. Alright, let's take a look at the next part. Equations relating polar and Cartesian coordinates. And this is a popular area where they like to ask the conversion between polar equations and Cartesian equations, right? X, Y equations and R theta equations. So these are the typical things we need to remember for equations relating the two sets of coordinates. X equals R cosine theta, Y equals R sine theta. R squared is equal to X squared plus Y squared, and tangent of theta is equal to Y over X. Okay, and these are some typical, here's the examples that connect between polar and Cartesian. Okay, so if R cosine theta equals 2, you know that R cosine theta is X, so you get the equation X equals 2. Okay, if you have R squared cosine theta sine theta equals 4, then you could say that xy equals 4, right? And a lot of these you could just do by algebra. You could split up the R squared cosine as R cosine theta and then R sine theta. Right, just split up the R and give it to the cosine and 1 to the sine. And you see that R sine theta is Y, R cosine theta is X. Okay, you do the same kind of thing for each of these. So let's do an example together. Example 5, find the polar equation for the circle. Okay, so let's find the polar equation for the circle. So keep in mind what this circle would look like. This circle would have a center at 0, 3. and it would have a radius of 3. Right? That's just going off of our knowledge of the circle formula. So when we're converting this, what we want to do is expand on the y minus 3 squared. So that would give us x squared plus y minus 3 times y minus 3. That would be y squared minus 6y plus 9 equals 9. We can subtract the 9 from both sides, so we have x squared plus y squared minus 6y equals 0. Okay, now into our conversion piece. We know that x squared plus y squared is equal to r squared, right? And then we have minus 6y. Now remember, y was equal to r sine theta. Okay, so we're going to put r sine theta equals 0. So we have r squared minus 6r sine theta equals 0. If we factor out an r, that means we would have r, pull out the r minus 6 sine theta equals 0. So to solve this, you could say r equals 0 or r minus 6 sine theta equals 0. Well, you know that the radius for the circle is not 0. We already stated what the radius was. It was 3. Right, so this one's out. Okay, so and then if we move the 6 sine theta to the other side, we would say r equals 6 sine theta. Okay, and that will be it. Let's take a look at some other examples. Replace the following polar equations by the equivalent Cartesian equations. Okay, so let's do the first one. R cosine theta equals -4. Okay, so we know what r cosine theta is. Right, r cosine theta is equal to x. So we can just replace r cosine theta with x. So that means we have x equals -4. Well, what kind of graph is this? Well, this graph of a vertical line. Right, vertical line going through x equals -4 on the x-axis. Okay, let's take a look at B. R squared equals 4 cosine theta. Okay, so remember the replacement for r squared. So r squared will be x squared plus y squared equals 4 r cosine theta. Well, r cosine theta, we just talked about it, was x. Okay. So we end up with this. So now what we could do is we could bring that 4x to the left. So we have x squared minus 4x plus y squared equals 0. Okay. So what we could do also, okay, left a little space here, we could complete the square here because we want to write it like an equation. If we complete the square, you see what ends up happening. So when we complete the square, remember completing the square, we take the square root of x squared, we get x. We follow the sign, we bring that down. We take half of the 4, which is 2. Now half of 2 squared is 4, so that means it's a plus 4 here and a plus 4 there. And so we have y squared equals 4. Okay. And so we see from here that this gives us an equation of a circle. All right, circle's center would be 2, 0. And the radius, take the square root of 4, radius is 2. Okay. And then let's take a look at part C. Okay, in part C, what we could do is I could multiply both sides by 2 cosine theta minus sine theta. So I have r 2 cosine theta minus sine theta equals 4. So that means I have 2r cosine theta, I could distribute the r, minus r sine theta equals 4. Okay, so I have r cosine theta, again, we see this trend again, r cosine theta is x, so I have 2x minus r sine theta is y equals 4. Okay, so I have 2x minus y equals 4. If I solve this for y, I could add the y and subtract the 4. I have 2x minus 4. This is an equation of a line. Right? It's a line with a slope of 2 and a y-intercept of -4. Okay. So that's it for this lesson. If you have any questions, just write me an email or bring it up during the lecture. Have a good day. Have a good night. See you soon.